I believe you can see my screen. All right. Let's talk about simulation. When you talk about simulation, it represents a model designed principally to mimic a real-life situation when making business and investing decisions using random variables. In the determination of expected value or in the determination of expected net present value using simulation method, the most important thing to do is to simulate for each variable of receipts and payments. Then step 2, you move to calculating net present value. So the result is what is called expected NPV using simulation method. In addition to that, the expected value method or the expected NPV computed using simulation method cannot produce optimal solution, but good enough or near optimal solution. The reason being that not all the cash flows of receipt and payments will be well represented because you are selecting numbers, you are selecting the cash flows on the basis of the random number given. So you are picking cash flows randomly. It may well be that the highest revenue may not be selected because your selection is based on the random numbers. Therefore, simulation method cannot produce optimal solution, but near optimal or good enough. Now, when you want to compute expected value, when you want to compute expected NPV using simulation method, so you need to first of all simulate for each variable of receipt and payments using the following formats. So whenever you want to simulate, okay, let me just show you. Simulating for cash flow. This cash flow could be receipts or payments. It could be revenue. It could be maintenance cost or variable cost. So the first item will be the cash flow. Okay, either receipt or payments. Whatever it is, it will be given. Then the next column will be the probability of occurrence attached to a state of nature. Okay. Next will be the cumulative of the probability in percentage. Okay. Then next item will be the random allocation. Random allocation. The random allocation, you are the one that will determine it. Then finally, you are going to have random number. It could be called random number or tag number. Either it is called random or tag number. It's the same thing. So this is how to simulate. This is how to simulate. So you are going to simulate for receipts and payments put together. All right, that's it. So once you are done simulating for receipt and payments, you then proceed to calculating the expected NPV. After you have computed the NPV based on the set number given to you, then you find the average NPV. So that will give you the expected NPV that you are supposed to calculate. So basically, simulation is very straightforward, only that you use computer integer to produce to run the random variables. Okay, so that's that. Yeah, so you can read more in your material to gain more knowledge on the probabilistic or Monte Carlo simulation. Okay, let's have illustration. All right. Yeah, let's have illustration number 6. Illustration number 6. Equity Pro Limited has prepared the following probability estimate for a proposed investment project. Cost of capital is 12%. Required. A. Calculate the net present value of the project. B. Analyze the risk inherent in this situation by simulating the NPV calculation. You should use the random numbers given at the end of the question to simulate 3 sets of cash flows. On the basis of your simulation results, what is the expected NPV? Explain briefly why the expected NPV calculated in A and B may not necessarily be the same. That is the question. Okay, number A, you are expected to compute the NPV of the project. So you want to calculate expected NPV of the project. What are you supposed to do whenever you want to calculate expected NPV? So simply, first thing first, we calculate the expected value of receipt and payment. In this case, the receipt is revenue, payment is running cost. So you multiply probability with the cash flow for both revenue and then running cost. Then you now use your expected value to go and compute NPV. That's what you need to do to get the A requirements, to satisfy the A requirements. Then number B, you have to analyze the risk inherent in this situation by simulating the NPV calculation. So you are expected to use simulation to also compute expected NPV, because in the question I can see the random numbers. I can see the random numbers as given. Okay. So what that means is that whether you are told or not, whether you are told to use simulation or not, once you can see random number in a question, it means that you are going to calculate expected value using simulation method, because it is only simulation that makes use of random number. So at this point, I will stop sharing and move to the working notes. Okay. All right. Solution to illustration number 6. Equity Pro. Okay. Number A, you are asked to compute NPV. Before you can compute the expected NPV, you need to calculate expected value for both receipts and payments. Therefore, I would then say calculating expected NPV. Okay. Calculating expected revenue. To do this, I'll create a column for probability, cash flow. The cash flow is the revenue. Okay. So let's just call it revenue. Then expected value. So the probability for revenue 0.15, 0.15, 0.40, 0.3, 0.15. Okay. All right. Expected value. Right. Okay. Then the revenue 40, 50, 55. 40,000, 50, 55, then 60. So to get the expected value, I need to get 15% of 40,000. That's 6,000. 40% of 50,000. 20,000. 30% of 55,000. 16,500. Then 15% of 60,000. 9,000. Add it up. Plus 42,500. That's 51,500. That's the expected revenue. I will also determine expected running costs. Expected running costs. Okay. We have three different probability. 0.4, 0.2, 0.35. 0.4, 0.25, then 0.35. Okay. That's the probability, running costs, then expected value. That's the expected running costs. Okay. So the running cost for the first probability 25, 30, 35. 25,000, 30, 35. Okay. So to get the expected running costs, I need to multiply 0.4 multiply by 25,000. That's 10,000. Next, 0.25 multiply by 30,000. 75. The last one, 0.35 multiply by 35,000. 12,250. That's 29,750. Now that I've calculated expected revenue as well as expected running cost, I can then proceed to compute the NPV. So I would then say calculating expected net present value. Okay. Year cash flow. Let's say description of items. Discount factor. According to the question, cost of capital is 12%. Then present value. Year 0, then the useful life of the product is 5 years. So year 1 to 5, this is initial outlay. Expected revenue will be here. Year 1 to 5, running costs will also be there. Okay. Right. Okay. That's the NPV, the expected NPV. So the initial outlay is 40,000 naira. Multiply by 1, 40,000. Expected revenue, we got 51,500. Expected running cost is 29,750. So we need to calculate annuity factor of year 1 to 5 at 12%. So 1 point, 1 point,
3.605.
pardon?
3.605.
Okay, so here is 3.605, 3.605. We then multiply that with the cash flow. 51,500 multiplied by 3.605. That's 185,658. 185,658. The running cost 29,750 multiplied by 3.605. That's 107,249. 107,249. Okay. Final answer. 185,658 minus 40,000 minus 107,249. 38,409. Positive. So examiner is asking that you should calculate the NPV of the project. That's what we have done. Okay, then number B, you have to calculate expected NPV using simulation method. Okay, so calculating expected net present value using simulation. Okay. So that's what you're asked to do in B. So the first thing first you need to do is to simulate for each variable of receipt and payment. Therefore, simulating for revenue. So create a column for revenue, create a column for probability, the cumulative of probability in percentage, random allocation, then random number. Okay, the revenue 40, 50, here is 40,000, 50,000, 55, then 60,000. Probability 0.15, 0.15, 0.4, 0.3, then 0.15. Okay, let me complete the table. Right. Okay. Just that. All right. So we need to find the last three columns. You are the one that will determine it. So we need to find the cumulative of the probability in a percentage. The first probability is 15%. Therefore, just write 15. We are looking for cumulative. So 15 plus 40 will give us 55. 55 plus 30 will give us 85. 85 plus 15 will give us 100. The next we want to do is to find the random allocation. Random allocation is just like class interval. So we are starting from 0, 0 to 1 minus 15 because you are using the cumulative of the probability to determine the random numbers. So 1 minus 15, the first figure is 15. So 1 minus 15 is 14. After 14 is 15. 1 minus 55 is 54. After 54 is 55. 1 minus 85 is 84. After 84 is 85 to 99. Okay, so that's the random allocation. I will then go back to the question. The random number given to me, what are the random number for revenue? For revenue, we have 30, 20, 79 for set 1, 2, and 3 respectively. So 30, 20, 79. So you now look at the random allocation that you have determined. Where does 30 falls? 30 lies in the second row, in between 15 and 54. That's where you have 30. Therefore, I have to indicate it there. We also have 20. 20 will lie in the same place, the same row. 20 is there. Then the third random number for set 379. 79 will fall here. So with this, I've simulated for revenue. I will do the same thing for running costs. Simulating for running costs. Okay. So running costs, probability, cumulative of probability in percentage, random allocation, random number. So what are the running costs? 25, 30, 35, 25,000, 30,000, 35,000. Probability of 0.4, 0.40, 0.25, 0.35. Okay, let me complete the table. All right. That's it. So we need to find the cumulative of the probability. The first probability is 40%. That's 40. 40 plus 25 is 65. 65 plus 35 is 100. So we need to find random allocation starting from 0, 0. 1 minus 40 is 39. After 39, 40. 1 minus 65 is 64. After 64 is 65, then to 99. I will then go to the random number given for running costs. 71 is the first one for set 1, 71. So I will look at the random allocation where does 71 lies. 71 lies in the last row. This is 71. The next one is 0, 0. Random number 0, 0 will fall on the first row. Here is 0, 0. The last one, 94. 94 will fall here. Again, with this, I've simulated for running costs. I've simulated for running costs. So now that you have completed the simulation, we can then proceed to compute the NPV. You can see in this question, you are given 3 different set numbers, meaning that you are going to compute 3 different NPVs. Once you have computed your NPV, then you now find the average expected NPV. That's all. Therefore, I would then say calculating expected NPV. So you are going to do this set by set. For set 1, year, item, cash flow, 12%, present value. Initial outlay is 40,000. 40,000. Year 1 to 5, revenue. Year 1 to 5, running costs. So I will then go to the question where I have the random number for both revenue and running costs. Set 1, tag number for revenue is 30. So tag number for revenue is 30 for set 1. This is where we have tag number 30 for revenue. You now trace it to the left where you have the revenue in value. That's 50,000 naira. So we select 50,000 naira for set 1 revenue. Set 1 for running cost, 71. Random number is 71. 71 lies here. That's where you have 71. Trace it to the left, that's 35. So you indicate 35,000. Okay, this is 3.605. So let's multiply 50,000 multiplied by 3.605 equal 182.50. Then 35 multiplied by 3.605, 126,175. The final answer. That's the MPV for set 1. So plus 40,000 minus 182.50, 14,075. That's the MPV of set 1. I will do for set 2. Okay, 40,000. 40,000. Yeah, 1 to 5, 1 to 5 revenue. The running cost. So for set 2, tag number for revenue is 20. I will then go to my simulation. Where can I find 20? 20 is still at the same place. Therefore, I will select 50,000 naira. Here is 50,000. Again, I will go back to the question. For running cost, set 2 is 0, 0. 0, 0. Here is 0, 0. Trace it to the left, that's 25,000 naira. Multiply by 3.605. So this still remain 180,250. 25,000 multiplied by 3.605 equal 9125. Okay, final answer. Plus 40,000 minus 182.50, 5125. Set 3, MPB for set 3. Right, 40,000 multiplied by 1, 40,000. You're 1 to 5, you're 1 to 5. So for set 3, revenue and running costs. Set 3, tag number is 79, revenue 79. Here is the 79. Trace it to the left, that's 55,000 naira. Revenue is 55,000. Then tag number for running costs. The last one is 94. 94 is on the last number there, the last row, which is 35,000 naira. Okay, 35,000. 3.605. So let's multiply 55,000 multiplied by 3.605 equal 198,275. Then 35 multiplied by 3.605. 126, 125. So NPV plus 40,000 minus 198,275, 32,100. So we're almost done. We have computed three different NPVs, and you need only one. So at this point, you need to find the average NPV. So average expected NPV would then be equal to, you add up the NPVs that you have computed, starting from 14,075 plus the second NPV of 5125. And the last one, which is 32,100. Because you added three variables together, you divide it by 3. Therefore, the average expected NPV would then be equal to 14,075 plus 5125 plus 32,100 equal to 96,300. 96,300 divided by 3 will then give us 32,100. This is 32,100. Therefore, the average expected NPV is 32,100. That's the question, but that's not the end. Number C, examiner is asking you to briefly explain why the expected NPV computed in A and the one computed in B may not necessarily be the same. Can somebody tell us why they are not the same? In the first calculation, in the expected NPV we computed in the A part, we got 38,409. Using simulation, we got 32,100. Why are they not the same? That's what the examiner is asking you. Do you know why? Ayodele, Debbie, Elvis, tell me, do you know why they are not the same?
The methods are different.
The methods are different. Yes, you are correct. Different methods are used to compute the expected NPV, so they can never be the same as a result. Okay, that's the answer. So number C. The expected NPV computed in A and B above are different because different methods are used in A above the expected value method is applied to compute the NPV. While in B, simulation method is used. However, it should be noted that the expected NPV computed using simulation method cannot produce optimal solution, but near optimal, near optimal or good enough because not all the cash flows are selected or well represented. That's it. That's the end of the question. Let me know if you have any question for me so that we can move to the next one, which is decision tree. Any question for me? If there's none, then move to decision tree. I'll stop sharing this. Okay, so let's talk about decision tree. What do you understand by decision tree? The decision tree is a pictorial representation of various courses of action involving complex situation in making business and investing decisions. Generally, businesses engage in merger and acquisition transaction, make or buy, international contraction, divestments, and so on and so forth. This kind of decision require meticulous efforts in order to maximize value for the company. So in making investing decision using decision tree, the most important thing to do is to construct a payoff matrix table. The payoff matrix table is a table that shows the decision variable, that is, the available alternatives, which are represented horizontally, and the state of nature, that is, the events in the economy, which are represented vertically. So the payoff matrix table will show the decision variables as well as the state of nature. That's the first thing you need to do. The second step is to construct a tree diagram. Then step 3, you assign probability of occurrence as well as the value to each node. Then step 4, you label the nodes alphabetically or numerically. Then step 5,
So
you
is it that
select,
your screen is not moving?
pardon,
Okay.
I can't hear you.
Don't worry, don't worry.
Talk to me, you are saying something.
Like your screen was not here before, so I was wondering.
My screen was not showing.
It's okay now, it's okay now.
Okay. So step 5, you select the alternative that has the highest expected value or expected NPV. So those are the procedures you are supposed to carry out whenever you want to evaluate using decision tree. However, when you are constructing your tree diagram, there are 2 nodes that you are going to use to draw your tree diagram. One is the decision node. The diagram will start with the decision node and it will also end with the decision node. What do I mean? When you want to construct the tree diagram, your starting point is from the decision node. Okay, you draw your decision node. So the arrow, the direction of your decision node will depend on the alternative courses of action. If you have only one alternative course of action, then in that case, just draw only one directional line. However, if you have 2 courses of action, then you draw 2 directional lines. If you have 3 courses of action available, then you draw 3 directional lines. So this is the way you are going to start with your decision nodes. Now, immediately after the decision node, you have to consider the event node. The event node is where you are going to assign the probability of occurrence and the state of nature. Remember, we said the state of nature is the events in the economy. You can have good, bad, worse. There could be success, failure, optimistic, most likely, pessimistic. You can have high, medium, low. All sorts of things can be the state of nature. All right. So that is that. Like I said, it is only when you want to make a decision that you are going to draw the decision node. This decision node is not necessarily that it's going to be only at the starting point. Even in between your diagram, you can have courses of action from which you are supposed to make a selection. So anytime you just want to make a decision or you want to select between or among alternatives, you have to draw your decision node. So that is as per that. I think at this point, you can then have illustration. Okay, so you can read more from your notes. Let's have illustration. Okay. Yes, let's have illustration number 7. I need one of you please to read for us. One of you should read, please. Who will help us? Yes.
Yeah. Let me read.
Thank you, Debbie.
The PLC is considering a project involving the outlay of 300,000, which it estimates regenerates cash flows over its 2 years life at the probabilities shown in the following table. Cash flows for the project. We have year 1, year 2. If cash flow in year 1 is, there's a probability of that cash flow in year 2 will be. Note,
Okay.
all cash flows should be treated as being received at the end of the year. The company's investment criterion for this type of project is 10% required. What is the expected value of the project's NPV? B, what is the probability that the NPV will be negative?
Thank you very much, Debbie. That is the question. So examiner is asking you to compute expected at this question. Number, the year 1 cash flow is very easy because examiner says you should compute expected NPV. You are not told to use any method. So when you look at the cash flow in year 1, it is easier for me to calculate expected value. But when you look at the cash flow in year 2, it's not the same thing because there are conditions. Okay, there are conditions given in that year 2. Therefore, I cannot use the expected value method to compute my NPV. In this case, I have to use the decision tree to estimate the expected NPV. All right, so like I explained earlier, you use decision tree when you are involved, when you want to make a complex business or investing decision, whereby you have sub decision to be made. There are conditional events that may occur. So as a result of that, you cannot use the normal expected value to compute your NPV. It has to be the decision tree because each of the method has its own unique way of computing or of incorporating risk. Under expected value method, you know that you just multiply cash flow with the probability. Under the standard deviation, you know that you are going to compute variance for you to be able to get your standard deviation irrespective. Then, under sensitivity analysis, you know what to do. You know the way the question will be tested, will be set. Under simulation, you know that once you have random numbers, then you need nobody to tell you that you're supposed to use simulation. So that is what we are saying here. When you have a complex business or investing decision to make, when you have a scenario whereby there are conditions given in the scenario, then of course you need nobody to tell you that you are supposed to use decision tree. So first thing first, examiner has helped us to we have been told that of course the cash flows have been put in the table, which made life so easy. At times, the cash flow may not be in table. So all the statement will be, the scenario will be painted in form of a statement. So you are the one that will now convert it. Like if you look at this illustration number 9, okay? So that's also, it can come out like that. Again, when you look at illustration number, let me say that's a particular question where you're supposed to use decision tree as well. Okay, maybe not, it's not here. But in any case, let's solve the question. Let's solve the question because of time. Please, I want to inform you whenever you have a question on decision tree, please don't make it your first attempt, especially if you are going to compute MPV, because it will take time. It's very straightforward. Once you get your tree diagram correctly, every other thing is very direct and straightforward, but it takes time, especially if you have so much, if you have many nodes, because it's expected that once you have drawn your tree diagram, you are going to compute MPV for each node. All right, so it would really take time. Okay, so solution to question number 7. Solution to illustration 7. Tin tin tin. Limited PLC. Okay. Now, exam tip. Whenever you want to construct your tree diagram, it's advisable that you make a rough sketch at the back of your answer booklet, not question booklet. Don't write anything on your question paper, because once you do that, the invigilator may think that you want to cheat. Therefore, don't write anything on your answer booklet, on your question paper. Whatever you want to write, if you write it in your answer booklet, if it's something that you don't need, then you cancel it later on. So whenever you want to draw a tree diagram, always make a rough sketch at the back of your answer booklet. Once you are satisfied with your drawing, then you can move it to the main page of the answer booklet. And when you are doing your drawing, please always use a pencil. Don't use pen, because no matter how good you are, even if you are an artist, no matter how good you are, you cannot have a perfect drawing at a first instance. There will be mistakes. There will be error that you may want to erase. Therefore, always use your pencil. That's it. So the starting point is to construct the tree diagram. And then when you want to construct your tree diagram, please make it very bold. Make it very bold. Okay. So with this, yeah, I would then say I'm starting from here. So you are going to start from the decision node. Okay. So I will then go back to the question. How many decisions? Let's read it. Let's read the question together. Tintin PLC is considering a project involving the outlay of 300,000 naira which is estimates will generate cash flow over its 2-year life of at the probability shown in the following table. So there is only one decision to be made. So if that is the case, so I will show only one directional arrow. Okay. So in year 0, we are told that the company wants to invest 300,000 naira.
Hello, sir. We are still seeing the question, or not your working on.
Oh, sorry about that. I thought I'm already sharing it. Okay. So we want to invest initial outlay. So I will come here, initial outlay, 300,000 naira. That's what we want to invest on the project. Okay. So immediately after the decision node, the next node that will follow will be the event node. Okay. I will then go back to the question. We are told that cash flows for project year 1. For year 1, we have cash flow of 100,000 at the probability of 0.25. Cash flow of 100,000 at the probability of 0.25. So let's go and represent that. 100,000. First thing first, what are the states of nature? Remember, probability are usually attached to state of nature. So if you have 3 probability, it means that there are 3 states of nature. Therefore, I will then come here. Let me reduce this cycle, this event node, because of space. Okay, that's okay. Now, first one, second, then third. Okay, so we have probability of 0.2. Okay, 0.25, 0.5, then 0.25. 0.25, 0.5, then 0.25. Okay, then cash flow in year 1, I told is 100,000 naira. Cash flow of year 2, 200,000, then 300,000. Sorry, we are still in year 1. At 50% probability, 200,000. Here is 200,000. Let me redraw that. Okay, that's too long. Later. Then at probability of 0.25, the cash flow is 300,000. Okay, that's it. So this is for year 1. So at the end of each one, I have to indicate the event node to close it, to close year 1. Okay. All right then. So I've closed year 1. I'll move to year 2. In year 2, we are told that if cash flow in year 1 is 100,000, there is a probability of 0.25 that cash flow in year 2 will be nil. So if cash flow in year one is 100,000, there is a probability of 0.25 that cash flow in year two will be nil. Here is nil. So if cash flow in year one is 100,000, there's a probability of 0.5 that cash flow in year two will be 200,000. Okay. Probability of 0.5 that cash flow in year two will be 100,000. Here is year two. Okay. Then, if cash flow in year one is 100,000, that's a probability of 0.25 that cash flow in year two will be 200,000. So probability of 0.25, cash flow will be 200,000. Again, I have to close that. Okay. All right. See now, thing is getting closer. So I will then move on. This one will not be able to stand like this. I have to redraw it because it's already close to the first one. In any case, let's move on. But before that, we have to redraw this one. It's too close. Okay. Let me put this one too down. You see now, this is what I was telling you the other time. So there will be mistakes. Okay. Let me push this one down a little bit. This is 300,000. Then 0.25 will come down to 0.25. Okay, we'll push this one down a little bit. Okay, and that's fair. No. You see the way I'm struggling with the drawing? That's why I say you should always have a rough sketch. Okay then. So let's move on. Yes, if cash flow in year one is 200,000, there's a probability of 0.25 that cash flow in year two will be 100,000. So here is a cash flow of 200,000. There's a probability of, what's wrong with you? There's a probability of 0.25 that cash flow in year two will be 100,000 naira. So here is 100,000. I will have to close that. Okay. Next, if cash flow in year one is 200,000, probability of 0.5 that cash flow in year two will be 200. So 0.5, 200,000. I will close the node. Okay. Then If cash flow in year 1 is 200, probability of 0.25, that cash flow in year 2 will be 300,000. So push it down. All right. 0.25. Cash flow is 300,000. Okay. Let me push that one to the front. Okay. That's it. Finally, again, I have to push this one down. It's still not, it's not looking good. I have to push it down. So let's do it this way. Better. Okay. That's too short. Okay. So if cash flow in year 1 is 300,000, there is a probability of 0.25 that cash flow in year 2 will be 200,000. Okay. Probability of 0.25 that cash flow in year 2 will be 200,000. Here is 200. Close the node. Okay. If cash flow in year 1 is 300,000, probability of 0.5 that cash flow in year 2 will be 300,000. Again, close the node. Finally, if cash flow in year 2 is 300,000, probability of 0.25 that cash flow in year 2 will be 350,000. So you close the node. That's it. So I'm done with the drawings. I'm done with the drawings. So at this point, all I need to do is to label my node, either alphabetically or numerically. So let's use alphabets. So to make it unique. So this, let's say this is A, B, C, D, E, F, G, H, I, J, K, L, M, N. So we are going to compute MPV for each of the nodes. That's the major work. That's what I said, that you should not make it your first attempt, because it will take time, especially if you have so many nodes. So at this point, I want to calculate MPV for node A. So I will then say calculating net present value, node A. So create a column for year, cash flow, discount factor at 10%, then the present value. 0. The initial outlay of the project is 300,000. We want to invest 300,000. Here is 1. 300,000. Okay. Year one cash flow. For node A. Here is node A. Okay. So in year one, the cash flow of node A is 100,000. Here is 100,000. 0.909. That's 9,900. In year two, the cash flow of node A is nil, 0.826, 0. Then the NPV will be equal to 300,000 minus 9,900. That's negative 209,100. Okay, I will do for node B. Do the same thing. Cash flow. Discount factor at 300,000 is the initial outlay. Multiply by 1, 300,000. Year one, year two. Cash flow of year one still remain 100,000 for node B, 0.909. That's 9,900. In year two, node B, year two cash flow is 100,000 naira. 100,000 naira. So here is 100,000 multiplied by 0.826. That's 82,600. Final answer. To 600 minus 300,000. 126,500. I will go to node C. Okay. $300,000 multiplied by 1. 300,000. Year one, year two. For node C, cash flow of node C in year one is 100,000. Year two is 200,000. 100,000. 200,000. 1909.
Excuse me, sir.
Yes.
Sorry, for node B, is it not supposed to be negative 126,500?
Yes, it is.
Okay.
Thank you. So 200,000 multiplied by 0.826 equal 165,200. Okay. 165,200 plus 9,900 minus 300,000. 43,900. 43,900 negative. That's the NPV of node C. Okay. Then node D. 1, 2, 3, 4, 5. 1, 2. This one cannot accommodate. So node D. This is very strenuous. Okay. Cash flow. Discount factor Present value. Year 0, 300,000 multiplied by 1. That's 300,000. Year 1, year 2. So for node D, cash flow in year 1 for node D, here is node D. Trace it to year 1, 200,000. Then for year 2, 100,000. So 200, 100. 200,000, 100,000. Multiply by 0.909826. 82,600. Then 200,000 multiplied by 0.909. 181,800. So 181,800 plus 82,600. Sorry, 82,600 minus 300,000. 33,600. 35,600 negative. That's NPV of node D. We are moving to node E. Okay. Present value. Year 0, 300 multiplied by 1, 300,000. Year 1, year 2. So for node E, cash flow in year 1 be 200,000. Cash flow in year 2 is 200,000. So here is 200, another 200. 0.909826. Here is 181,800. Then the other one is 165,200. 165,200. So NPV will be equal to 165,200 plus 181,800 minus 300,000. That's 47,000 positive. Then I'll move to node F. Okay. The same value. 300,000 multiplied by 1. Year 1, year 2. For node F, year 1 cash flow for node F is 200,000. Year 2, 300. 200. Then 300. 192,909. 826. 185. 181,800. Then 300,000 multiplied by 0.826. Error. 300,000 multiplied by 0.826. 241,800. MPV.
So it's 247,800.
247. Oh, I typed 0.806 on my calculator. Thank you. So you said 247, right?
Yes, sir. 247,800.
All right, thank you. 247,800. Then 247,800 plus 181,800 equal minus 300,000. That's 129,600. Then node G. 1, 2, 3, 4, 5. Let me use the other one. So node G. Cash flow 10%. Yeah, 0. 300 multiply by 1, we give 300. Year 1, year 2. So for node G, year 1 cash flow is 300. Year 2 cash flow is 200. So 200. Three 200. 0.909826. So here is 165. 165 watts. 200. 165, 200. Then 300,000 multiplied by 0.909. 272, 700. 272, 700 plus 165, 200 minus 300,000. 137, 900. Node I done F. Yes, I've done F. F, G, H. Node H. Cash flow 10%. 300,000. Multiply by 1. Year 1, year 2. So node H. Year 1 is 300,000. Year 2 is 300,000. 300,000. 300,000. 909,826. So here is 272, 700. Then 300,000 multiplied by 0.826. 247,800. So MPV plus 272,700. 272,700 minus 300,000. That's 220,500. Okay. Node I. Node I. Okay. Zero, 300,000 multiplied by 1, 300,000. Yeah, one cash flow for node I is 300,000 multiplied by 0.909, which is 272, 700. Year 2, cash flow for year 2 is 350 multiplied by 0.826. 350,000 multiplied by 0.826. 289,100. 289,100 plus 272,700 equal minus 300,000. 261,800. Okay, so that's for node I. Then node J. We are done with H. We are done with I. Then we move to, we have 5 more nodes to go. So we are going to node J. So for node J is coming from node A, B, and C. Therefore, we are going to combine the NPV of node A, B, and C for node J. So for node J, let me see if I can manage here. Node J, combine the NPV of nodes A, B, and C. So node A, B, C, NPV. Where did this one go? The figure I put here before. What was that? 261,800. 261,800. Okay. So NPV of node A, we calculated. Oh, God, where I move it to? We calculated for node A. NPV of node A was 209,100, 126,500, then 43,900 for A, B, and C. 209,100. Please be calling the number for me. Here is 209,100. What's NPV of node B? We calculated
126,500.
126,500. Node C
43,900.
43,900. All negative. Then we include probability because for node J, there's a probability of 0.25. Okay, under for A. So here is 0.25. Here is probability of 0.5, then 0.25. Then we get the expected value. So 209,100 multiplied by 0.25 equal 52,275. Negative 126,500 multiplied by 0.5, 63,250. Then 43,900 multiplied by 0.25, 10,975. Negative Add it up. Okay. Plus 63,250 plus 52275 equal 126,500. Here is 126,500 negative. Then I'll move to node K. Again, for node K, when you look at what we have in our diagram, node K is coming from node DEF. Node K is coming from node DEF. Therefore, you combine the MPV of node DEF for node K. All right. Combine the MPVs of node D, E, and F. Okay, so node MPV probability, then expected value. Node D, E, F. What's MPV of node D?
Please, Mr. De Jong, can you go up a little bit?
Negative
How about
36,500.
What did you say is the number?
Negative 36,500.
36,500. Node E,
47,000.
47,000 positive. Then node F,
129,600.
129,600. So, Mr. Robert, you say I should go up.
just a little?
Is it okay?
Yes, it's okay.
Can I go back?
Yes.
Okay. So probability of 0.25, 0.5, 0.25. So we get the expected value. 36,500 multiplied by 0.25 equal 9125. 9125 negative. Okay. Then 47,000 multiplied by 0.5, 23,500. 129,600 multiplied by 0.25, 32,400. So the expected value plus 23,500 minus 9125. That's 46,775. 46,775. Okay. Node L. Node L. Yeah. Sorry, what am I saying? Node MPV. For node L, we are combining. Let's go back there. Node L. Here is node L. So we are combining node GHI. MPV of node GHI. Combine. the MPVs of nodes G, H, and I. G, H, I. What's the MPV of G?
137,900.
137,900. H,
220,500.
220,500. I,
261,800.
261,800. So expected value 137,900 multiplied by 0.25. 34475. 220, 500. 0.5. 110, 250. 261, 800 multiplied by 0.25. 65, 450. Okay. Plus 110, 250 plus 34,475. 210, 175. So we're done with node L. We are moving to node M. Node M is coming from node JKL. Node M is coming from node JKL. So you combine the MPV computed for node JKL, then you multiply with the probability. So combine nodes MPVs of nodes J, K, and L. J, K, L. What's the MPV of node JK? Node J,
Negative 126.
Negative 1,500.
126,500 negative. Node K,
46,775.
46,775. Node L is
210.
210,175. Probability of 0.25, 0.50, 0.25. Okay. So 210 multiplied by 0.25 equal, that's 52,544. Here is 52,544. Then 46,775 multiplied by 0.5. 23,388. 23,388. Then 126,500 multiplied by 0.25. Negative 31,625. Therefore, 52,544 plus 23,388 minus 31,625 equal, something is wrong. Something is wrong. 2, 3, 3. 54, 52, 544. Yeah. This is giving me 44, 307. Supposed to be 44, 419. So something is wrong. Something is wrong. This node D, let me confirm that node D first. Node D looks somehow. Node D. MPV of the node D. Let me confirm the accuracy. Okay. 82, 600 plus 181, 800 minus 300,000. 35,600 is correct. Let me see node C.
Okay, so I think I saw 36,500 for node D. That's
Node-
under node K.
Under node K. Node K, node K, node K. 36,500. Yes. Is it not 36,500?
35,600.
35,600.
Oh, error. 35. This should be 35,600. So 35,600 multiplied by 0.25. 8,900. This should have been 8,900. So 8,900.
No, it's 9125.
No, is it nine? It's not
Okay, so
name.
sorry, 30. Okay, I think I'm wrong.
Yeah. So 23,500 plus
7,000.
32,400. That's 47,000. This should have been 47,000. Okay. So I need to go and update 47,000 for node K. Yes, 47,000. Multiply by 0.5. 23,500. So 23,500 plus 52,544 equal minus 31,625. That's 44,419. That's
Yes.
it. Thank you. 44,419. So that's it. That is for M. The last one is N. Node N is coming from node M. Node N is coming from node M. Therefore, whatever you have as M is equal to your N. So I will then say node N, node N equal to node M, which is equal to 44,419. So the expected value is 44,409 naira. So examiner is asking you what is the expected MPV. So I will then say the expected MPV is 44,419 naira. That's it. That answers number A requirement. Number B, you are asked what is the probability that the MPV will be negative? the probability that the NPV will be negative. So to answer that, we are going to look at the NPV computed originally. Where do you have negative NPVs? So you then multiply the probability of the negative NPVs for year 1 and 2. Whatever you have will represent the probability that the NPV will be negative. You will see that originally we computed node A. Node A gave us a negative NPV of 209,100. Node B, negative NPV of 126,500. Node C, negative NPV of 43,900. Node D, negative NPV of 35,600. That's the first negative NPV. Any other NPV, negative NPV you got is a sub, it's a combined negative NPV, not the original one. So the original NPV, negative NPV is for node A, B, C, and D. Therefore, to get the probability that the NPV will be negative would be the NPV, the probability of the nodes with negative NPV. So let's quickly indicate that. Number B, the probability that the NPV will be negative represents the probability of the nodes with the negative NPV as shown in the calculation below. So we have node, we have workings for the probability, then we have probability. We have identified node A, B, C, and D as the node with negative NPVs. So for node A, probability of node A in year 1 is 0.25 multiplied by probability of node A in year 2, which is also 0.25. Probability of node B in year 1 is 0.25 multiplied by probability of node B in year 2, which is 0.50. Probability of node C in year 1 is 0.25 multiplied by probability of node C in year 2, which is 0.25. Probability of node D in year 1 is 0.50 multiplied by probability of node D in year 2, which is 0.25. Let me confirm that. Okay.
Correct.
It's correct. Okay then. So in that case, let's find the answer. So I would then say 0.25 multiplied by 0.25 equal to 0.0625. 0.25 multiplied by 0.5 0.125, 0.0625, 0.125. So we add it up. This will give me 0.3. Let me see. Multiply by 2. That's 25. Then plus 0.0625 plus 0.0625. That's 37.5. So 0.7375. Therefore, the probability that MPV will be negative is 37.5%. That's it. That's the end of the question. That's the end of the question. This is very tiring. Okay, so that's what I said, that you should be very careful when you are given, when you have question under decision tree, especially if it will require that you need to compute MPV. It could be tedious depending on the number of nodes that you have in the question. So, but again, every areas of your syllabus is important because you never can tell. It may well be that that's even the one you know the most. So, and if you are ignoring it because it's tiring, then you're not doing yourself any good. Okay, then. So that's that. So I'm not sure. It's been a while, for so many years. I don't know if I can be asking you question on decision analysis. So maybe I will let me just solve one question on that decision analysis so that at least we know that we cover all grounds. Okay. Let's talk about decision analysis and we close the class. Ordinarily, I wanted to stop the class before, but I don't know. Let me see. Let me stop sharing. Yeah. Let me see if I can spend the remaining 30 minutes on decision analysis. I'm not sure. I doubt if examiner can be asking you a question on that decision analysis. But in any case, let's run through it. Okay. Is there any need for it? There's no need. It's just a waste of time. It means performance management. Yes, examiner can be asking you this, but not in SFM. Not in SFM. So let me know if you have any question for me, please. If there's no question, we close the class for today. And then we meet next time by the grace of God when we shall be having, we are going to start merger and acquisition versus business valuation in our next class. So yeah, that's from me to you. I will see you next time by the grace of God. Good night, everyone.
Thank you, sir.
Good night, Jibri. Debbie, Gloria, everyone, good night.
Good night, sir.
Good night.
Good
Good night,
night.
sir.
Good night, Mr. Roberts. Baby, I did not hear your voice.